Okay, this is TempleOS 5-minute random code walkthrough episode 57, and I'm your host, Terry Davis. Let's see where we are today. Disk cache invalidate 2. Okay, this is in the in the kernel disk code. Let's see where it's called. Find disk cache invalidate. There's invalidate and invalidate locks it, initializes if it has a read cache, invalidate 2. So this is the actual. So the disk cache is an array of. Let's see how I can. Disk globals. So there's a cache block has least recently used, least recently used, a hash, a partition, the body of the block itself. So the blocks are 512 bytes. And this is the block number, this is the partition, and so the cache is an array of cache blocks, and we have the head of the queue is the control, and the hash table is when I say they're hashed, let's say it's just the block number modulo the number of cache blocks plus partition or something. Anyway, disk cache invalidate. So if the disk cache has been created, then we lock the cache. There's a lock bit for the cache. So we yield to the next task until we get this is locked bit test and set. This is atomic. Then we start at the beginning of the cache, and we go all the way through the cache. Well, we're not back to this is the head. The control is the head of the doubly linked list. This is we're going in reverse order, going last. So this is what we're going to update, and if this cache block is allocated to this partition, then we remove it, set it equal to 0, and reset its hash links, whatever that is, and we insert it in the least recently used. Okay, so it's been freed to be reused. then we release the lock on the cache. So when we the way the hash works is it's the block modulo the size, and then we throw in I thought we threw in the partition. No, I guess not. So different partitions will hash to the same hash entry. Also, after it has an alias or doubles up, whatever you want to call it. The hash is an array, and the least recently used is a circular doubly linked list. Let's look at how we read. We read a cache block. Read cache blocks. No, let's look at how we write. Oh well. Okay, well, that's that.